This lecture is about effect modification and interaction and the meaning of these concepts in epidemiology research. There are distinctions between the terms effect modification and interaction, as described by Van der Waal. Effect modification, also described as effect measure modification, heterogeneity in association measure. Think about it when the objective of the research is to investigate whether the strength of an association measure related to exposure varies across the strata of another exposure or characteristic. To understand interaction, think about a research with the objective to investigate if the observed occurrence of an outcome, like lung cancer, measured as risk or rate, you would like to see if this occurrence of this outcome among persons that are jointly exposed to two exposure, for example, smoking and asbestos, if this risk or rate is greater or lower than what is expected in situation of independent effects of smoking and asbestos. For effect measure modification, let's see an example of with quantitative outcome use linear regression. In this situation, the regression coefficient of the product terms reflects modification in the association as a departure from additivity. We have here two different situations. Situation 1, where there is no effect modification, and situation 2, with effect modification. Why you say that is no effect modification in situation 1? You have here an association between exposure or a predictor with an outcome. And using linear regression, you see that this line for group A and group B, this line are parallel. In this situation 1, you may say that the strength of the association between the exposure and the outcome is the same for group A and group B, even though you have for group A the mean is greater than the mean for group B, but no effect modification, because what determines here is the strength of association. Each increase in exposure determines the same increase in the outcome for group A and group B, then absence of effect modification. In situation 2, you may see these lines are not parallel. You see that what we have read for group A, you see that the inclination of the slope for group A is greater than the slope for group B. This means that the association between exposure and the outcome is stronger for group A than group B. These lines are not parallel, in fact, they cross. The fact that these lines are not parallel indicates that the association between the exposure and the outcome varies depending on the third variable that determines if the group is group A or group B. This difference in the strength of association between exposure and the outcome across levels of the third variables indicates effect modification. The effect modifier variable in this example is the third variable. Let's see a situation of absence of effect modification in the association between sex or gender and a measure of quality of life. And we look for if there are variation in this association between person that older or younger. The codes are for gender, 0 for male, 1 for female, and for the third variable age, 0 younger and 1 older. The quality of life score is a continuous variable, and high score means better health related quality of life. In general, the health related quality of life, or the reported health related quality of life for several scores are lower in women than men. The score of quality of life compare women with men is similar among the older and the young group, what means absence of effect modification. If you test this using a coefficient to test for effect modification or like heterogeneity in this association, you see also a very large p-value, what means also absence of effect modification. We have now an example of effect modification in the association between sex and another scale of health-related quality of life. And you see here, among the older, if you compare women and men, you have a very large difference of about 10 points, and lower here, approximately 4 among the younger. This represents effect modification, and the statistical test for the heterogeneity in the measure, you see here, p-value, very low p-value. And this number here of approximately 6 in the coefficient of heterogeneity represent this difference between these two groups of approximately 10 in the older and approximately 4 in the younger group. As you may see, effect modification in the linear regression represent a departure from additivity. For dichotomous outcomes like this, the presence of effect modification and interaction depends on the model, that's to say, if it is based on risk, like or ratios, that is would be multiplicative, or differences, that would be in this case additive. I will talk about effect modification and interaction for dichotomous outcomes in the part 2 of the lecture.